We're going to look at this homework problem, then we'll go on and get started with today's third. Now, looking at this here, well, it started a little bit ago. 9:56 is when it starts. It is 10:17. Now, the first thing we want to do with 51 is get the radical by itself. Well, it's already by itself, so we don't have to do anything there. Now, we square both sides. So on the left-hand side, the square root and square will simplify out. On the other side, we have 2a squared. Well, 2 squared is 4, and a squared is, well, a squared. Now, since we do have a squared term, we have a quadratic, so we do need to get this equal to 0. So we can add 3a to both sides. So we have 4a squared plus 3a. Then we can subtract 1 from both sides, which will tell us 0 is equal to 4a squared plus 3a minus 1. Now, we could try to graph this one, but unfortunately, we're going to probably have fractional solutions, mainly because we do have 4a squared. So we're going to have a fraction somewhere. But we should be able to factor it and go from there. Now, since the third term is negative, our signs are opposite. Factors the first and third term. Well, third term's kind of nice because the only factors of 1 are 1 and 1. 4a squared, well, we'll have a and a. And factors of 4 are 1 and 4 or 2 and 2. 1 and 4. And we'll put the 1 with in the positive and the 4 with the negative, because if we check this here, 4a times 1 is positive 4a. 1, so a times negative 1 is negative a, which does give us positive 3a. Whenever we have two things multiplied together equal 0, one of them must be 0. Here we can subtract 1, telling us a is negative 1. On the other side, we would add 1 to both sides. Then we would divide by 4, telling us a is 1/4. So we have negative 1 and 1/4. Now we can check both of these here. So if we check negative 1, square root of 1 minus 3 times negative 1 is equal to 2 times negative 1. Well, on the right-hand side, we have negative 2, so most likely this is not going to work. And if we simplify the radical on the other side, we would have 2 is equal to negative 2. So a equals negative 1 doesn't work. Because with the radical, 1 minus 3 times negative 1, the negative 3 times negative 1 would make 3, plus 1 is 4, gets us this here. Now with 1/4, 1 minus 3 times 1/4 is equal to 2 times 1/4. Well, 2 times 1/4 is 1/2. Second, square root 1 minus 3 parentheses 1/4 is indeed a half. So a half equals a half, so our only answer is a equals 1/4. Questions on any of this here? Okay. Now, what we're going to look at next is the notes for today. The note sheet for today. Has anybody seen London today? Okay. Yeah. Okay. All right. So we're going to look at this here. Now, this here is one of the problems that actually involves step 3. Because when we looked at the steps for solving radical equations, the first step, is there one radical? If so, get it by itself. Just in time. So first step, if there's one radical, get it by itself. If there's more than one, even it out. So if we look at this here, we do have them evened out, so that works nicely. Our second step was to put both sides to the nth power. And in this case, we'd put both sides to the second power and we'd work this out. And then step 3 was, if there's still a radical, repeat steps 1 and 2. So for us here, when we look at the left-hand side, we just have the square root of 2x. Well, square root and square will cancel, leaving us with just 2x. On the other side, we have the square root of x plus 7 minus 1, and we're squaring it. Just like yesterday, when we talk about this here, we're saying the square root of x plus 7 minus 1 is being multiplied by the square root of x plus 7 minus 1. We're multiplying it by itself. Now the left-hand side is going to stay 2x, and it'll be there for a step or two as we work out the right-hand side. Now the first thing we're going to do is multiply square root of x plus 7 times square root of x plus 7. Which is saying that we have the square root of x plus 7 squared. So if we wanted to, we could simplify the square root and square out, and that will simplify there. The next one is we have the square root of x plus 7 times negative 1, which will be negative square root of x plus 7. Then we do the same thing with negative 1. Negative 1 times square root of x plus 7 is going to be negative square root x plus 7. And lastly, negative 1 times negative 1 is plus 1. Questions on any of this so far? $2x. Now we already said the square root and square for this here are going to cancel out, leaving us with x plus 7. Well, we also have a 1 over here, yes? Well, 1 and 7 make 8. So we can combine those two like terms. Now the other like terms that we have are these two radicals. So we have minus, we have 2 times square root of x plus 7. Now, we finished combining like terms, yes? So we finished doing that step, step 2, and this is where step 3 finally does come in, because all the other problems we've done so far are dealt with. Step 3 didn't make any impact, because step 3 was, if there are still any radicals, repeat steps 1 and 2. At this point here, we do still have a radical. So we go back to step one. Is there one radical? Yes. So we get it by itself. So this is where step three comes in. Because of the fact that the one side had a radical and a number, we had to multiply it out. And after we finish multiplying, we still have a single radical left over. So at this point here, we're just repeating the steps again. So we're going to get it by itself. So the first thing we can do is subtract x from both sides. 2x minus x is x. Then we can subtract 8, which gives us x minus 8 is equal to negative 2 times square root of x plus 7. Is the radical by itself? No, we've got to do what? Divide both sides by negative 2. When we divide both sides by negative 2, we have the square root of x plus 7 is equal to x minus 8 over negative 2. So we've got the radical by itself, yes? So now, step 2, put both sides to the nth power. So we're going to square it again. And on the left-hand side, the square root and square will cancel, leaving us with x plus 7. And at this point here, now all the radicals are gone. So it took us 2 times through this to get them to go away, but we were able to get them all to simplify. Now we do need to square the other side. In our properties of exponent, it says if we have a quotient, something being divided inside of a fraction, we can apply that square to the top and bottom. So to the numerator, we're saying we have 8 minus x, or sorry, we have x minus 8 times x minus 8. The numerator is being squared. The denominator is also being squared at negative 2, so we have negative 2 squared, or negative 2 times negative 2, which is indeed 4. So on the other side, we have 4 on bottom. Now in the numerator, we can multiply this out. X times x is going to be x squared. X times negative 8 is negative 8x. Negative 8 times x, negative 8x, and negative 8 times negative 8 is plus 64. Now we can combine like terms. Our negative 8 minus 8 will give us negative 16 plus 64. Yes. Questions on any of this so far? Now, the next thing that's kind of making things a little bit challenging is the division of 4. Would we agree with that? So there is a nice trick that we can do. Yes. Because if we multiply the entire right side by 4, the 4 cancels. Because that's using a scalar, and especially in solving problems where we have decimals, we can multiply by base 10, so 10, 20, or 10, 100,000 to move all the decimals over, make them nicer numbers. Or we can find a scale number to multiply everything by to make the numbers work out nicer. Because on the left-hand side, 4 times x is 4x. 4 times 7 is 28. On the right-hand side, we have x squared minus 16x plus 64. Since we have an x squared, we have a quadratic. We need to get this equal to 0. So one of the things we'll need to subtract from both sides is 4x. We can also subtract 28. And again, I believe I've said this in here before. Normally, especially in Algebra 1, when we cover doing these, we did them in single steps, mainly so that we don't overcomplicate it and have too much stuff going on. But I feel for us, or feel that y'all at this point can keep those two steps separate and do them at the same time, because 4x minus 4x is 0. 28 minus 28 is 0. So we still have x squared. 16x minus 4x is negative 20x. 64 minus 28 be plus. That is 6. 36.
I mean 36.
Yes, you got it right. So, since x squared is our starting term, we can actually type this in. X squared plus or minus 20x x plus 36 graph. So we do see one location that it does cross the x-axis. Yes? So second table. So one of our solutions is 2. So x equals 2 is one of the solutions. Now we know there should be a second one, yes? Now, it's been a while since we've done this when we talked about the properties of quadratics. Since the number in front of x squared is positive, it tells us that it opens up. And looking at these numbers, if it's opening up, as we go out to either side in behavior, they should go to positive infinity on the y values. So if I notice that the y values as x goes negatives are increasing, that means it's not going to have a 0 there. Since after 2 we get into negatives, at some point it should turn around and start going positive. So I can keep going down to try to find the other 0, which is at 18. So the two solutions for this are 2 and 18. And with most of these here, it's always going to be good to check them, just to make sure. So on the one side, we have the square root of 2 times 2 is equal to the square root of 2 plus 7 minus 1. Right, so we could do that, and square root of 4 is 2. So the entire left side is 2. On the other side, we have square root of 2 plus 7. 2 plus 7 is, square root of 9 is 3. And again, if this was, we're checking something on the test, plug both sides individually into the calculator. If they come up to be the same, we write it as, say, 2 equals 2. We're done because that is checked. We can do the same thing with 18. Square root of 2 times 18 is equal to the square root of 18 plus 7 minus 1. So we could say second square root of 2 times 18 is 6 is equal to second square root of 18 plus 7 outside minus 1 is So our one solution is 2. Questions on this here? So we don't have time to do the other one. Because 4 minutes. I mean, if you want that to be your homework question.
No. Oh. They're over. Do you have homework? I thought he was gonna hand out like
no.
works. I thought it was
Now, again, I'm not doing a homework assignment over this because this is above and beyond what the standards state.
Oh.
But I wanted you to see it. I wanted you to be able to see this.
Can I get extra credit if I do this and get it right?
So, what I wanted y'all to see with this here is that even though that these problems do look harder, because this has three, because even this here, it looks harder than it is. Because for the most part, it's just when we took it step by step, we got them evened out, we squared both sides. None of the steps or individual steps going from one to the other were any more difficult than what we were doing before. But the amount of steps and stuff we had to do did increase a lot. But from step to step, it wasn't anything that y'all couldn't do. And I wanted you to see it and see how it works so that you kind of had seen it, but we're not going to specifically test over this. Okay?